Good morning, Year 4, and welcome to Maths Learning for this week. I hope you're all safe and well and that you've had a lovely weekend. We're going to start this morning, as per usual, with our warm-up. We've got 5 questions for you to answer. Try and get as close to 5 minutes as you possibly can. As always, there are 2 written method questions and 3 that are requiring to use a mental strategy. Press pause while you're working and press play when you're ready to hear the answers. Okay, the first question we're going to look at this morning, question A there, 3 times 2 times 2. First method I would use, and this is probably my favourite method, would be to multiply the 2 smaller numbers together, or the 2 numbers that are the same. In this case, it's 2 times 2, which we all know is 4. And then I would multiply this number by the larger number. So 3 times 4 equals 12. Second method, you could just multiply the first 2 digits. So 3 times 2 would give you 6, and then multiply this by the remaining number. So you've got 2 left, so it will be 6 times 2 equals 12. Doesn't matter which method you use, and I've put in red at the bottom here. It's a really important thing to remember that with multiplication, you can multiply in any order. Remember that word, commutative law. We've talked about it this year, okay? And it means you can switch the order of the numbers around when you're multiplying, and you'll still get the same answer. Okay, second question we're going to look at, question B there, 85 divided by 4. This one we're going to say you could use pencil and paper for. And I'd be thinking for the first method, I'd be using a short bus stop method of division. Okay, so we would line up the columns properly. And the question is basically asking us how many 4s go into 85. So if we start with the first part here, we would say 4 goes into 8 twice. So we put the answer up there, 2. And then the last thing we're here with the last division part of this question is how many 4s go into 5? Well, we can get 1 4 and there is 1 left over. So you have a remainder of 1. So the answer then would be 21, remainder 1. Second method, we could partition the number into 80 and 5 and then divide both parts by 4. So 80 divided by 4 would be 20. And 5 divided by 4 would be 1, remainder 1. And if you recombine the numbers, so 20 plus 1, remainder 1, would equal 21, remainder 1, which is the same answer as we had for method 1. Either method works well. Okay, we're going to look at question E now. It's one of those sneaky questions where we have 144 divided by a mystery number will equal 12. Well, really, actually, when we strip it down, this is a times table fact question. First thing we need to do is rearrange the number sentence, move things around so that the question mark comes, or the mystery number comes after the equal sign. Okay, so if we change it here, we're left with 144 divided by 12 equals our mystery number. So really, that's asking us how many 12s are in 144. And as I've put down here, we then use our times table knowledge to work this out. So 144 divided by 12 equals 12. And I've put in brackets here. We know this because 12 12s are 144. Okay, next question we're going to look at is question C. And the question is 1/5 plus a 10th. Now, this is different from the fractions we've been looking at so far because the denominators are not the same. Okay, so what I've done is I've laid out 1/5 here as a fraction bar, and I've laid out 1/10. Now we can see that 1/5 would equal the same as 2/10. Okay, so really what I would suggest we would have to do is turn the denominator, okay, into tenths, so it is both the same. So 1/5 is the same as 2/10. So we would write 2/10, and then we would add 1/10. Now we all know how to do this because when we're adding fractions with the same denominator, we know that the denominator stays the same, and then we just add the numerators. So 2 plus 1 is 3. So the answer to the question would be 3/10. The final part of our mental strategy, mental warm-up this morning, we've got here question D, and it's a straightforward addition question this morning. So 7,493 plus 2,428. So first method would be addition, standard method of addition, sorry, not division. What I want you to do then is to line up your columns. Most of us are familiar with this, so it shouldn't be a problem. 3 plus 8 is 11. And we need to carry the 1 over into the tens column. 9 plus 2 would also be 11, and we carry the 1 across into the next column as well. And then 4 plus 4 is 8, and 1 is 9, and then 7 plus 2 is 9. So we get an answer there of 9,921. Now our second method could be to partition. So 7,000 plus 2,000 would be 9,000. 400 plus 400 would be 800. 90 plus 20 is 110. And 3 plus 8 would be 11. And then if we recombine that number, we would end up with 9,921, which matches the answer up here. Okay, moving into the main part of the lesson today, our learning intention is to be able to draw lines of symmetry today. So our star words this morning would be symmetry, lines, draw, shape, or figure would be another word for shape, and reflect. Okay, our in focus question this morning is to look at this shape here, to look at the shape here as a whole. And it says, does this figure or shape have lines of symmetry? And the young lady here is asking how many. So we might need to use some of the knowledge that we've already gained in the last lesson. Have a little think, press pause. What do you think you need to know to answer this question? Okay, well, first thing we're going to think about to the last lesson, is how we were able to fold the shape over. And if we were able to fold it over and exactly fit the shape onto the other side here, folding along this dotted line, then we would know that it would have a line of symmetry. The big question we need to think about in this question is there more than one? And that's what we'll try and unpick over the next few minutes. Okay, let's learn. So first thing, the first part of this session, we'll be thinking, actually, this is using what I looked at yesterday. It's a bit like this dotted line being a mirror. Okay, now if we had this shape, we could fold it over exactly, and it would cover up the shape exactly on the other side here of this dotted line, the fold line. It also would be a bit like looking in a mirror. Okay, so this dotted line, if we said it would be like a mirror line, what we have on this side of the line has to look exactly the same as what's on the other, a bit like when you look in the mirror. In this case, we can see that this shape has a vertical line of symmetry here, because this side is exactly the same as this side. As the character here is saying, the two halves match up exactly. This young lady's saying that she drew this line, a horizontal line across. And she's also saying that the top half is a reflection of the bottom half. The two halves are exactly the same. They're exact copies. So if we folded across this line here, or we reflected in this line here, if this was our mirror, if the top is the same as the bottom, then this also is a line of symmetry. So we now know that this shape has a vertical line of symmetry that we looked at on the last slide, and then this one also has a horizontal line of symmetry as well. So there are two lines of symmetry so far. Now this young lady has drawn a dotted line, a diagonal dotted line across this shape here. So the same shape. Why is this, the question there is, why is this not a line of symmetry? We've already said that the vertical line through the middle meant that there was a line of symmetry, and the horizontal line across had a line of symmetry. Why is this not a line of symmetry? think about what we've talked about in the last few minutes and yesterday's lesson. Press pause now, and then we'll come back together when you're ready by pressing play to talk about why this isn't a line of symmetry. Okay, so this dotted line here goes diagonally up. Now we said, if you remember, this dotted line is just like a mirror. If we were to fold the shape over, then it should fit exactly on top of the other half of the shape on the other side of the line. Or if we were to have a mirror on this line, what you have on one side should look exactly the same as what you have on the other. If we were to fold this over, it wouldn't lay exactly on top of the other shape. So that means it cannot be a line of symmetry. So going back to the question at the beginning, how many lines of symmetry does this shape have? Well, we've said and we've proved that it has two, a horizontal line and a vertical line. Okay, now it's your turn. There are four shapes on the page here. What we want to know now, how many lines of symmetry, well, first of all, does each shape have a line of symmetry? Can you find the line of symmetry? And then if you get that done, could you think about how many lines of symmetry each shape might have? Press pause now while you're working and press play when you're ready to look again. Okay, so all of the shapes do have a line of symmetry. Now you can see that this one here only actually has one line of symmetry. And you can see that the line is the same on one side of the shape as it is on the other. So I'll get it as accurate as I can. It's not perfect. None of these would be though, because when I looked at the shape itself, when I tried to draw other lines of symmetry on, the shape wasn't exactly the same on both sides of the line. So it only actually had one. The star here, every line I cut from point in a straight line vertically down, and I had to move the shape around to do this, had a line of symmetry. So there was 1, 2, 3, 4 lines of symmetry. 1, 2, 3. Actually, I've missed one out here. I need an extra one. Mr. Nugent. Let's try and get this on. Sorry, it's not a dotted line, but pretty much it's not as accurate as I would like it, but you can see that every point has a line through it, and that is a line of symmetry. So for each point, there's 1, 2, 3, 4, 5 points. So there will be 5 lines of symmetry in that shape. The octagon down here has a vertical line, and it has a horizontal line, and it has 2 diagonal lines of symmetry as well. So it has 4 lines of symmetry, and the same with the hexagon. 1, 2, 3, and 4. Now have a look at these letters. It obviously spells out the word hexagon, a 6-sided shape. But what we're looking at here, or what we want you to look at here, is first of all, how many letters might have 1 line of symmetry, which letters have 2 lines of symmetry, and which letters have more than 2 lines of symmetry, and which letters have no lines of symmetry at all on this shape. Press pause while you're thinking about it, and press play when you're ready to move on. Okay, so first part here, which letter has 1 line of symmetry? So I think I'm going to go through all of the letters in turn and talk about how many lines of symmetry they have. Well, the letter H here has a vertical line of symmetry, which would go down through the middle here, and it would have a horizontal line of symmetry. Okay, so it would have 2 lines of symmetry. The E wouldn't have a vertical line because it wouldn't look the same on both sides, but it does have a horizontal line of symmetry across here. So it has 1 line of symmetry. This particular X has a vertical line of symmetry, and it also has a horizontal line of symmetry. So it has 2. The letter A here doesn't have a horizontal line of symmetry because the shape wouldn't look the same, but it does have a vertical line through the middle. So it has 1 line of symmetry. Now the G here doesn't have a horizontal line of symmetry, it doesn't have a vertical line of symmetry, and it also has no diagonal lines of symmetry. So this is one of those shapes here that has no lines of symmetry. The O here, this sort of square O here, it has a vertical line, it has a horizontal line, and it has two diagonal lines. So that would have more than two lines of symmetry. And finally, the N doesn't have a vertical line of symmetry, it doesn't have a horizontal line of symmetry, and it doesn't have any diagonal lines of symmetry. So that's our second shape that has no line of symmetry in it. Okay, now it's your turn to have a go at your independent learning this morning. What I'd like you to have a look at is worksheet 6, please, on pages 134 to 137 of your workbook. This should be an extension of what you've been learning this morning about lines of symmetry in shape. Have a go at it. Press pause now while you're working and press play when you're ready to come back. Okay, well done, year 4. You've got to the end of the lesson. Have a good day, and I will speak to you tomorrow. Stay safe and goodbye.